Question 5. So we're looking at simple harmonic motion. An object of mass capital M is connected to a pair of identical springs as shown. Part A is show that M will oscillate with simple harmonic motion, SHM, when given a small horizontal displacement x. Okay, so this question, we're just trying to analyse the situation and see whether it obeys the definition of simple harmonic motion. So what is simple harmonic motion? It is motion that is periodic, and it's characterized by a restoring force which is proportional to the displacement. So we just have to have a look at this situation and see if there is obviously it's going to rotate and spring back and forth, but we have to see if that restoring force is proportional to displacement and show carefully that it is. So if it was just on a single spring, so if we're just considering one side of it, we would be applying the F equals minus K x, where minus shows that the forces in the restoring forces in the opposite direction to the extension x, K being the spring constant. But we can see that the force is clearly proportional to the displacement, and it's in the opposite direction. So if you compress one spring, so say we compress on this side, so we've moved by the displacement x that way, then there'll be a restoring force in the opposite direction that way. Now at the same time, because we have to consider both sides of this, we've moved to the right there, we've stretched it out, and there will also be a force on this side, and that'll also be a minus kx relationship. So we can see exactly the same thing. The force, or the restoring force, will be in the opposite direction, that's the negative, and it's proportional to the displacement x. So really we're combining it in an addition, so it's still directly proportional to the displacement but in the opposite direction. So yes, this is following simple harmonic motion. That's what that's getting at. Okay, part B. The oscillating mass starts with zero momentum and when released from its initial displacement. At the midpoint of the motion, so I guess passing through the equilibrium position, the system seems to have gained quite a lot of momentum. This appears to contradict the law of conservation of momentum and explain why there is no contradiction. Okay, so clearly there is some stored energy in the springs. What we have to determine is whether that stored energy being released is violating the laws of conservation of momentum, because there's zero momentum to start with. And remember, momentum is always conserved. And it does seem kind of an odd question until you understand what it's getting at. But basically, there are forces involved which are causing an acceleration. And the acceleration is increasing the momentum, or leading to some form of momentum. What we have to show is that that force is not pushing against nothing. So the force, if you like, there has to be a reaction force in the opposite direction to accelerate something else and to give something else momentum in the opposite direction. And in that way, there is no momentum gained from nowhere, but momentum is conserved. So we have to work out, we have to follow the chain of forces to find out where that momentum goes. And it's quite simple, really. You just have to think on a fairly large scale. So here's our spring on one side with a fixed position on the other, and a spring on the other side with a fixed position on the other. What we don't see in this picture is the supports are attached to the earth. And if you've moved this small displacement x, and then it begins moving from the stored energy, a force is applied to start it moving this way, through the supports, force is applied equal and opposite to the earth in the other direction. Now clearly the mass of the earth is so much bigger than the small mass of the mass being accelerated between the springs. So there's negligible or unnoticeable momentum gained by the Earth, but there is a very small amount, and you could work that out if you wanted to. But since the Earth is obviously ginormous, the change in momentum would lead to no noticeable effect. So that's what's going on. And just make sure we've answered, explain why there's no contradiction. So if we are dealing with a narrow, like a small system like this, where I'm drawing the dotted lines, then there is a violation. But it's not a closed system. It's not as simple as that. The Earth is part of the system, so you have to consider the whole.